Alright, we are here and back. Today we're going to explore the graph and what it could do for us as developers. So the graph is an indexing protocol that allows us to query Ethereum, and it's really neat how it works. Let's just dive right into it and pull up the Graph Explorer. These are all subgraphs that people have developed and deployed to the graph node. Let's take a look at SushiSwap. I think this is a good example. And if you're not aware of SushiSwap, it's an exchange, a decentralized exchange. If we hit the playground real quick, you'll see we have all of these entities, which we'll define in a little bit. We'll walk through how that's created. So for example, if you take a look at this token entity, it has all of these traits. One thing you'll notice is that when we have a relationship between two entities, for example, the factory, which is related to the token, we're not gonna give the ID of the factory, right? That's not efficient, right? If we did the ID of the factory, we'll have to do an additional search within our entities to say, all right, what factory does this ID match? Here, what we're doing is we're actually placing the actual factory object or entity in the place of the ID. So when you click on it, you'll see that you'll have this full data structure that's returned in the place of the factory. This is really useful because when we query, we'll do in a little bit for certain data, we get everything we request for back within one query, right? We don't have to do additional queries with foreign keys and making those relationships. So let's go ahead and take a look at how we can do a simple query. So let's just get the first 5 users. This is what this first line is saying. And let's just get the IDs as well as their liquidity position. And again, let's look at the entity. So the user, it has a liquidity position, and within that liquidity position we have the option of getting the ID, the user, the pair, liquidity. So it's just a tree. It's an ongoing tree. So another thing you can return is the pair, right? So we did the pair and we did that, and then the pair has, you'll see a factory, right? And this is how we can dig deeper, and this is just within one query. So within the pair, let's say we want the name, and then we also want the reserve 0, right? And these are just numbers, and the reserve 0 is just a value. It's a big decimal, and the name is just a name of string. So this will return to us users and then ID. So this is the first ID. So user 1, this is their liquidity position, this is their liquidity position ID, and then within that liquidity position, this is the pair, the name of the pair, and then reserve 0, and then that's one user. And then you go on to the next user, and that's going to do the first 5 users. So this is a really neat way of looking up data on Ethereum, and you can do this with any smart contract. You just have to set up the subgraph and deploy it and start using it. So what we're going to attempt to do is set up one for the Bored Ape Yacht Club. This is going to be my first time walking it through, so we'll run into some hiccups, but we'll kind of figure it out and learn through it. So let's get straight to the development. Alright, so I have the Subgraph Studio pulled up. You can access it by going to thegraph.com/studio. It's going to require you to connect your MetaMask wallet. I'm going to attempt this on the Ethereum mainnet, and let's see how it goes. So the first step is creating a subgraph through the studio. And let's call it Bored Ape Yacht Club, and let's choose the Ethereum mainnet. Hit continue. You'll see that's undeployed because of course we haven't deployed it yet, but we're gonna go ahead and follow the steps to go ahead and deploy it. You can see you also can fill out some description, source code URL, website URL, as well as categories. We're not going to worry about that right now. Now that we have terminal opened up, you want to make sure you have npm or yarn installed. I am using npm, and what you're going to do is install the graph binaries locally, or globally I should say, and I already have it installed. Once you have graph installed, you can do a double check and type in graph-v, and it's going to return you the version you have installed. We initialize our subgraphs boilerplate code by typing in graph init followed by the contract name, and then we want to specify that we do want to index the event, and then specify the product flag followed by Subgraph Studio, because that is what we used. And then we want to specify from contract, and I got this contract address from Etherscan of the Bored Ape Club. Bored Ape Yacht Club. I can't talk. And let's go ahead and give it a shot. It's going to ask us to select a protocol, select Ethereum, and then we are using Subgraph Studio. And our slug, I believe, is the BAYC. And then hit enter. And then we'll just keep the directory there. And we are doing mainnet. The contract address there. And then contract name. See. I'm just going to use that. Okay, it's going to go ahead and install some dependencies. Alright, so you'll see that we have created the boilerplate code. So if we cd into the directory and do an ls, we'll have all of the required files and folders to continue. Alright, so what I went ahead and did is opened up the directory and Visual Studio Code so I can better visualize the files. What we're going to first take a look at is our schema.graphql. This is where we define all of our entities, and just delete the default entity there. So the first entity I'm going to make is an ape and label it as an entity. And then I want to give it an ID, and then I want to give it a ape ID actually. And then content URI, and then let's do created at, and then let's do the creator, and then the owner. And you'll see that the users will also have to be defined as an entity, so let's go ahead and do that. Do type user, define its entity, and then we'll give it an ID. We'll also specify all the apes it may have. And then to create one-to-many relationships, we say derived from, and then we specify the field where this is derived from. I can't spell today. And this is going to be owner, because every owner will be yes. And then we'll say created. We'll also keep track of any apes that this user may have created, and we'll say derived from, and then the fields owner, or actually creator. And then let me install a plugin really quick. I'm installing the GraphQL extension. Perfect. Alright, so this looks good to me so far. Next thing we want to take a look at is our subgraph YAML. This is going to allow us to describe our configuration for our subgraph. You'll notice that a lot of this is already pre-populated. We want to add a couple of things here. So first thing we want to focus on is the data source. So right here it says source. We want to specify the start block where the data source should start listening. If we don't specify the start block, it's going to start listening from the Genesis block, which can take a long time to sync. And then we specify that in our start block. The next thing we want to modify is our entities. We want to update this to match the entity that we created in our schema. So we have the ape and the user. The next thing we want to do is update the event handlers to only keep the ones that we want to work with. Let's just keep the transfer. So once we have updated that, let's go ahead and open up our terminal and run the codegen command. So it's graph codegen and then graph build. It's gonna generate some files that we're gonna edit. Okay, so we have cool. All right, so we have this new generated folder, which within it you'll have a TypeScript file that is a representation of the Bored Ape Yacht Club smart contract, and it's going to allow us to interact with the smart contract using this. And you'll see it also generated the schema file, which we're not supposed to edit. So the first thing we want to do is open up the mapping.ts in the source folder and import a couple of things. We're going to import from, let's see, generated, and then it's Bored Ape Yacht Club, and then let's grab the TypeScript that we looked at a little bit ago, and then from within it we're going to capture the transfer event as transfer event, and then we want to go ahead and import our entities. We have the ape and the user generated like this. Okay, so now we have imported those, and let's update that. So the first thing we were going to want to write is the handling of the transfer function. So let's go export function handle transfer, and we're listening for this event, transfer event, and then return void. And then we want to say so this line we're writing right here is going to look up the data store for the specific ape that we just captured in the transfer event. So let's go ahead and say toString from to token ID. Okay, this is token ID, not ape ID. And this is params. Okay, got it. So this is just essentially loading up from the data store again the ape that we just captured in the transfer event, and then we want to check if it's actually existing, because this could be the first time the graph node is encountering this ape. So let's do a check. So we're saying if ape does not exist, then we create a new ape and store it in the data store. So say new ape, and then every time we do event.params, it's essentially extracting the data that is emitted with the event. So in our case, token ID is a part of the transfer event. So let's go ahead and extract that and convert it to string. And then once we have that ape, let's say we're going to set all of the fields. So ape.creator equals event, and then I'm just going to say 2 hex string. Okay, and then we have the ape dot created at timestamp, and then we'll just get the block time this event was captured. So this is a simple mapping that we are updating. One thing we forgot to import is the contract itself. So we forgot to import the Bored Ape Yacht Club as Bored Ape Yacht Club contract. And then from there, we're going to declare a new variable, call it ape contract, and then say Bored Ape Yacht contract dot bind, and then event dot address, essentially binding that contract address to that contract. And then we'll say ape dot URI, content URI. So we've captured the content URI directly from the smart contract address, and we just looked it up using the token ID. So this smart contract address is going to have multiple apes identified by an ID, and then we just capture that and look up the ape contract for that specific content URI relating to that ID. So that handles the case when the data store does not contain that ape, and that's the first time we encounter it. Now let's continue and say ape.owner, and we're going to set that equal to event.params, and we're going to do the recipient address, and we'll say 2 hex, and this is essentially because the recipient is going to be the new owner, and we'll say ape.save, And this is using the GraphQL library that allows us to interact not only with the smart contracts themselves like we did in this manner, grabbing the content URI, but we're also able to save directly to the data store after we make certain updates. So next thing we want to do is load from the source, the data store I should say, the user. So we'll say user and then load events, and then we're gonna look for the recipient address and see if we can locate them in the data store. And we'll do the same check we did up here, because this may return null if the data store does not have this user, and this is the first time we encounter this user. So to account for that, we'll say if null, we'll say user equals new user, creating this new user, which we can store in the data store. New user, and then events.params.to, and then do the same thing to hex string. And then we're going to go ahead and say user.save, so we have it available for us in the data store. Alright, so it looks like we have the transfer function handler created, and everything looks good so far. Next step would be attempting to deploy it and see if it works. So next thing we want to do is log in or authenticate ourselves using our deploy key, and you can find that once you are at this page. Just scroll down and copy our authenticate and CLI, and then open up your terminal and paste it here. Alright, so I'm just going to clear my screen so I can unblur it. So I'm officially authenticated and I'm able to deploy. So to deploy our subgraph that we just created, we just have to type in graph deploy -- studio and then the slug of our subgraph. So let's go ahead and enter. You can ask us to specify a version. This is the first version. Let's just do v0.0.1. Okay, so it looks like we have deployed it. Let's refresh this. Looks like it's syncing, and we have the playground available to us. And you'll see the entities that we created are appearing. So you'll have our ape, which has the ape ID, URI, creator, which leads to actual user, having that one-to-many relationship. So let's try to query really quick, see if it actually works. So I'm going to try to query for users. What we're going to get is the ID of the user, as well as the apes that they own, and as well as any apes that they created. And within the apes that they own, we'll just return the ape's ID. Same thing with the apes that they created. We're just going to return their ID. We get the address for the first user, and looks like he has two apes, so number 37 and 38. He has created both 37 and 38. This one looks like he has a lot of apes, which he created all of them too as well. And then the next one, he only has one ape ID number 65. This one has 3 apes, so on and so forth. So this is a really neat way for you to look up the Ethereum blockchain. That was a really simple implementation. Obviously, there are subgraphs that are a little bit more complex and allow you to see more detail and make sense of it. But of course, this is just a demo. Even then, it's pretty amazing to kind of see in one query, first 100, right? We can get the first 100 users and all of the apes that they get. This can be really useful when you're developing applications. Let's say you're populating a grid for all of your token holders. Instead of having to maintain an on-chain mapping within your smart contract, or even an on-chain server or off-chain server, to maintain and update all of those data points, we can just deploy Subgraph, and every time there's a transfer of ownership that happens, this is going to get updated using the logic that we wrote. Again, that was my first time trying out the graph and hooking it up to actual smart contract and then mainnet. So I'm glad to see it working. I do want to go back and revisit this and do a little bit of a deeper dive and understand how I can make this a little bit more complex so I can one day use it. I'll probably make a follow-up video with like a part 2, which is a little bit more advanced than what we did today. But I think this helped me, and as well as hopefully helped you get an idea of what the graph is, how we can tap into it as developers. So thank you very much for tuning in. Make sure you like this video if you enjoyed it or learned something new today. Drop a comment with your thoughts, questions, concerns, anything that comes to mind. And of course, make sure you subscribe to this YouTube channel and click the notification bell so you get notified every time I upload a video. I will see you in the next video. Thank you.